Okay, here are the three conditions that have to be true in order for this function, which is a piecewise function, to be continuous at -5. First of all, the limit of the function as x approaches -5 must exist, which implies that the limit as x approaches -5 from the left must equal the limit as x approaches -5 from the right. Also, f of -5 must exist. And finally, the limit as x approaches -5 f of x must equal f of -5. It's not a very good -5 there. Okay, so let's go to Desmos and see what that actually looks like. First of all, here's a definition of f of x as a piecewise function. On Desmos, we give the partition of the domain that we're going to look at first, followed by a semicolon. So when x is less than -5, f of x is defined as 3x plus 18, which is this line right here. When x is greater than -5, it's the square root of x plus 14, which is this line here. And when x equals -5, the function value is -2, which is this point down here, and there's where the cause of the problem is. I didn't put this point on here. Let's see why that's not shown here. I'm not sure. Okay, anyway, here's a table that shows you what's happening as far as the limit goes, and you could evaluate the limit by direct substitution. But as x approaches -5 from the left, you can see that f of x is getting closer and closer to 3, 2.99997 down here. And as x approaches -5 from the right, like -4.9, again, we're getting closer and closer to 3. And so the limit from the left does equal the limit from the right. So the limit exists. It's 3. But f of -5 is defined, and it is defined as -2, but the limit does not equal the function value. 3 does not equal 2. And so you could think of this as what we call a jump discontinuity. And as we're coming in closer and closer to this -5, 3, to continue drawing the function, I'd have to jump down here to this point and then back up to continue the function definition. So this is also called a removable discontinuity. If we just change this rule to be a 3, when x is -5, y is 3, then all of a sudden the function would be continuous because the limit would equal the function value. Okay, there you go. So we're back to here. This is the condition that is violated for continuity. The first two are satisfied, but the third one is not. Okay, there you go.